For that, you have to narrow it down, and you give a bigger LLM or an orchestrator access to these tools or these sub-agents. And then based on the user query, it's going to decide like what to call, when to call, how many times to call, and when to stop and give the answer back to the user. That's where like semantic similarity doesn't work that well. And you would want to use keyword search. And a combination of both are the best. Always look at the data, figure out what the issue is. And that is where I was saying, like, whatever you build is not going to be the final solution because you will have to keep working on it. You created a nice feedback loop for them to like keep improving their documentation and make it more diverse. It's obviously not trained on your proprietary information that's within your company. So you would want to use a RAG system there.
Are you using RAG? And if so, are you using it correctly? We all know that context is king, and RAG is one vital component of optimizing your context. But are you using it right? Do you even need to use it at all? On episode 63 of Tool Use, brought to you by ToolHive, we're joined by Apurva Misra. She's the founder of Sentick, an AI consultancy that helps companies of all sizes with their AI strategy along with building AI solutions. We're going to deep dive into RAG. Do you need a re-ranker? Do you need to cache? What are some non-technical solutions to allow everyone to benefit from this? So please enjoy this conversation with Apurva.
I'm hoping everyone has used ChatGPT. That's why AI is hyped up right now. Like everyone knows about AI thanks to ChatGPT. So if you want to use AI in your system, and if you're thinking of like building a customer support solution, for example, you have like HubSpot documentation, you have the HubSpot knowledge base, you have made like a bunch of YouTube videos, and you want to provide like a layer on top of that that people can come and ask questions to, and it could like look up from these sources and answer to the people, that is a rack system. Or like basically like any sort of like sources that you have inside your company, and you want to build a layer on top of it so that users can communicate with it in natural language, that I would call a rack system. And it's not just like communication, like it's not just conversation. Rack system could be just Q&A, like asking a question, getting an answer, like filling out an RFP document. So it could be, it's just basically a rack system is you have a lot of documentation, you have a lot of videos, you have a lot of knowledge, proprietary knowledge that the LLM is not trained on, but you want the LLM to utilize that to answer. And that's where you build a rack system. So if in simple terms, if you think about it, you can go and attach a PDF document in ChatGPT and ask questions, ask it to summarize it, ask it to do a lot of things with that PDF document. But what if that PDF document is really long? Or you have a lot of PDF documents and you want to do the same thing to that? That's where you would use a rack system. So what it does is it breaks down your documentation into like chunks, pieces, and then it would go embed it and save it in like a vector DB. And then when you ask something, it would go and find like the relevant chunks and then run the LLM layer on top of that so that it's able to like summarize it or answer a question out of it. So that's what a simple rack system does. And this is why you need a rack system. You can do it simply. A rack system is basically like providing the LLM the information that it doesn't have so that it can answer your questions or like do a task for you based on this information. But because there's something called context window, there's a limit of how much knowledge it can go over at one time. You would want to like use a rack system so that it like breaks it down and embeds it and like does a search over it and gets you the relevant chunks when it's needed to answer your query.
Excellent. Yeah. And there's a few things I want to go a bit deeper into, but one thing that comes up on the internet a lot, and you hear the controversy around it, is, oh, RAG is dead. We have million context windows. What are your thoughts on the ability for us to just cram everything into the context and let the AI figure it out versus a RAG system, which is going to more granularly select data to inject into the context?
So there's a paper which has come out, and in there's a graph where it shows, even though the context window is going up, if you look at the performance of these models with these like bigger context window, after like a certain length, like 200K or something, like the performance plateaus. So it doesn't like improve. So there is, I feel like, I guess it's going to keep increasing. The context window is going to keep increasing, but how the current LLM architecture is set up, it's still not going to perform as well. Even though the context window is like 1 million long. Like if you put like anything more than 200K tokens, it's not going to perform as well because it's not able to focus. LLMs are like, I keep telling my audiences, they have ADHD. If you put too much in the context, they get confused. And with like any like enterprise company, there's so much that you have to explain in the context. For example, if you're a trucking company, you will explain what a DOT number is. Like explain anything that's proprietary to your company that it should know any of those acronyms. And then you would give that, pull that relevant chunks from the documents. Then you will ask, put like some sort of cautionary prompt here, don't answer to these kind of queries. And so the prompt goes so long and there's so much that the LLM is doing that it's not able to focus. So it's very important to just give it the important chunks instead of giving everything. Because when you start building a production ready system there, you would not think like the prompt goes really big. It becomes really big. Like when you're trying to explain everything, trying to do a complex task, giving it examples, few short learning. So it grows really big. So it's always important to like keep the context focused on what you're trying to do. So you would want to pull only the relevant stuff instead of giving everything in there. And like to your previous question that you asked, like why would business leaders would want to use RAG? The other piece is also that I mentioned. There's a slide in my like presentation that I have, which is like you want to use RAG system because these LLM models. If you think about like the recent model, I think got released by Anthropic. It was trained on data till like January 2025. So if you are, I don't know, a news company or something and you want the latest information, you would want to use RAG system because it doesn't know what happened last week. So it doesn't have that. Unless you provide it the search tool, it has to go like search. Otherwise, it doesn't have that knowledge within that model. So that is where a RAG system comes handy. The other is like your proprietary knowledge, so these are like two important things. It's not trained on the latest information. You would have to provide it the tools like web search. Otherwise, like it's obviously not trained on your proprietary information that's within your company. So you would want to use a RAG system there.
One thing I want to touch on that you brought up is embeddings. So I have a collection of PDFs from company policies to user interviews, just a hodgepodge of different things. If I take those and want to embed them, what's the workflow like? Maybe give some examples for if you have an engineering team so you can build something in-house, or for the less technical, an online or a digital service. How do I take my PDFs and turn them into this magical format that LLMs can ingest?
So embeddings are basically numbers. So if you think about it, it's basically a vector of numbers. So an array, and you have numbers inside that. So it could be like generally models are like 1536 length long. It depends on the embedding model that you're using. So how long of a vector it gives out. So you can give it like a chunk. So embedding models also have a context window. So you can give it a chunk of like a certain limit, and then it would give you a vector for that chunk. So the pipeline for this ingestion would be basically you ingesting your PDF documents and then you're breaking it into smaller pieces. So in some cases, you don't even have to break it into smaller pieces. For example, when I was working with the startup to build a customer support bot for them, their HubSpot knowledge base, they were answering questions that the users were having by writing documentation for that. So like for one question, they have like maybe one pager or two pager, and you can you don't have to break it into pieces. You can just like put that into an embedding model and you can get a vector out of it easily. So it depends on your use case and your kind of documentation, like how would you want to chunk it? But you would want to chunk it so that it makes sense. For example, if the PDF is small enough, please don't chunk it. If the PDF is really big and you have to chunk it, it's better if you overlap the chunks a bit. For example, the PDF is this long and you're chunking it, might as well like overlap it a bit. You have like 50 tokens overlap so that this chunk has the context of the previous chunk. And also you might cut it like midway of like whatever it's trying to say. So like maybe do the breaking at like a new line, or there's a paragraph change. So like something like that, like chunk it thoughtfully. The other thing is, also, there is something called, which was a blog post that got released by Anthropic. It's called like contextual retrieval. So if you are in a domain which is more complex, for example, healthcare, you can also use an LLM to summarize what the whole document was and put that at the top of each chunk. So this chunk is like number 2 in this PDF, and this document was talking about Alzheimer's. And then you do the embedding so that it has some context in there of the whole document and it's not lost. What I'm trying to get at is it's very simple. You have to chunk it, you put it in an embedding model and create a vector out of it, and you store that vector into a vector DB. That's what an ingestion pipeline is simply. But it can be very complex when you're working in a production system, and in whichever domain you're working in, like you would have to play around with these parameters and figure out what works best for you. The next thing is the embedding model. Does the embedding model make sense for your use case? For example, you can use an embedding model. OpenAI has a bunch. Other companies also have a bunch of them. There are open source embedding models like the Nomic ones, and also there are multimodal embedding models. So if your PDF has images, you can embed them in the same space. Or you might want to do this. You might want to take the image, create text out of it, and then embed that. So like you can go like multiple ways. But the other thing is like the embedding model that you're using. For example, if you're building a system which is focused on customer churn, for that system, a sentence like, I want to subscribe to your service and I don't want to subscribe to a service, like are two very separate sentiments, and you want them to be far away in the embedding space. So you can filter by it. So that's where you might want to train your own embedding model. So you can like fine tune your own embedding model as well based on your requirements. But otherwise, mostly I've seen these embedding models work fine, but sometimes there's a need to like fine tune your own embedding model.
You mentioned some of the metadata about like the document that the chunk was found and whatnot. Is there a risk of putting too much metadata when you're working with some embeddings? Or is it kind of ideal to try to add that extra context so the model knows where this chunk came from?
I would say it's never too much. So one is the contextual retrieval piece that I was saying. So you put the summarized stuff at the top of the chunk and then you do the embedding. The other thing is the metadata. So metadata is like what was the file name this chunk is from? Like when was it last modified? So date modified or date created, that could be one thing. And then what's the page number? So metadata mostly depends on your use case. For example, the healthcare company that I'm working with recently, the kind of queries that they are getting are two kinds. One is the Q&A, that is like a typical RAG. Like people have questions and you can find answers inside the document, and you would have to pull the like relevant chunks and then answer the query. The other kind of questions that they are getting is like file search questions. In this folder, how many documents do I have? Like how many HR documents do I have? Can you find me this vendor's this document? So that's where you would figure out like you need more metadata. So having more metadata is not a bad thing. It lets you like filter first based on the metadata, and then you do the retrieval. In that case, like when we do the ingestion pipeline, see now it's getting more complex. Like when you focus on the ingestion pipeline, you do an LLM call, ask it to like, based on this document, what do you think? Is this an HR document or is this an IT document? And that would be a metadata field as well. It's an HR document. What page number? So like it depends on the use case, the kind of metadata you want to save, but like more metadata is not a bad thing. So when you're doing the retrieval, what you would do is like based on the query that the user has, maybe you would do metadata filtering first. Okay, the user wants to get documents from last month, so I'll filter by date from those documents, and then I will do my semantic search, that is like embedding matching, and like get those relevant chunks. So it helps you with latency as well, because you're doing semantic similarity on less number of documents, and also helps you improve the results.
I really like that. And I think we'll come back to it because the idea of optimizing these pipelines is super important. But one thing I want to bring up before I forget is you mentioned the potential for fine tuning an embedding model. And I actually haven't interacted with anyone that's got to the point where they need it. But just for evaluating the existing embedding models, do you have any strategies for testing to see how this actually works? Do I need to explore other ones? How do you go about like evaluating an embedding model?
You would evaluate the embedding model based on the retrieval. So is it doing the retrieval how I expect it to for my use case? For example, like I was giving an example about like subscription and not a subscription. So what I would do is like choose an embedding model. Like there's MTEB, MTEB ranking on Hugging Face. You can find that, and you can filter it. Like they have like nice filters. Like if you're doing classification, like how the embedding models are ranked, which language are you focused on, which are multimodal. So it's a pretty nice leaderboard. You can like find an embedding model from there. And once you get that embedding model, what you would want to do is like embed your stuff, like embed like a few documents, and then you would want to like type a query on that and see how it's retrieving from the vector DB based on those embeddings. And if those embeddings do not make sense, you might want to like play around with like chunks and stuff. But if it does not make sense for your domain, like how you want the embedding to look like, if it doesn't, you can obviously like plot it as well in 2D. Like you are actually compressing the high dimensional thing into two dimensional. If it doesn't make sense for your use case, you might want to like fine tune or like go check out some other embedding model. So that is how you would do it. Visualization is one thing. The other thing is just testing it out, honestly. And then the leaderboard there is like really helpful on figuring out which embedding model to use.
For the vector DB that you mentioned, there's a few big providers. What do you recommend people explore when they're looking for a vector DB? Are there certain criteria you have for different use cases, or how can people accelerate finding the right vector database for their use case?
So whenever I'm working with a company, the first thing I do is like look at the current tech stack, and if they're using Postgres, might as well just add the PG vector extension and use that as the vector DB. You wouldn't want to like start using a new technology unless it's needed. And generally, I've noticed is like that's enough. That's just enough. Like using Postgres with PG vector is enough. But I have realized Pinecone has a nice UI. So like anyone who is new and working in this technology, like Pinecone is amazing that way. Very nice UI. It helps you understand like you in the UI itself, you can do like top K, like put the ID of like whichever chunk you want to find similar chunks to. You can do like top K. Very nice UI there. Then you have a bunch of other vector DBs as well. But what I've realized is like unless you have like millions and millions of document and like latency is becoming a big deal, you don't have to look for specialized solutions. Postgres with PG vector is good enough. And honestly, like if you're using any of these technologies already, might as well stick to it. For example, like if someone is using Postgres, I would like just add PG vector and start using it. I would not go and find a new vector DB and try to add that into their tech stack.
And I'd echo that. I use Postgres as my database at Box One, and we set up PG Vector. So it works. It works. It's right there. You don't have to add a new stack. It's just reducing complexity. And especially these things do sound complex. I did want to give a quick shout out. We had a previous guest on, Kirk Marple. He has a company called Graphlet that kind of abstracts away all this, where you can just like a nice drag and drop interface. And it's a nice way to kind of get started, but you do lose a lot of control if you're not pulling it in-house. But different needs, different use cases. Do you have an idea or like a heuristic around when people should go for one of those hosted managed services versus bring things in-house?
Depends on how much money you have and and how many resources you have in-house. If you have a lot of engineers in-house and you can utilize them, you can like do it in-house. Otherwise, like if you have a lot of money, get a managed service. Managed services are always easier, obviously. And they like right now, like Pinecone introduced serverless, like it's quicker, cheaper as well. So it depends, like it's a trade-off between like how much money you have and resources you have in-house. Otherwise, I feel like Postgres with PG Vector, since you're already maintaining Postgres, like it's just an add-on onto it. So it's not a lot of effort in-house either.
One thing that comes up a lot is the quality of data, where garbage in, garbage out. It's very important that you try to add context where possible. Do you recommend people doing their first RAG pipeline to just dump the data in, like just copy and paste all the PDFs into their workflow? Or should there be some degree of pre-processing? And if so, what should they look for to try to improve the quality of their data?
So yeah, you have to do a bunch of things there, but all my answers are going to be it depends. It depends on your use
Yeah,
case.
yeah.
But for example, like deduplication is one thing. So when you're working with enterprises, deduplication is like the most important. The other is also RBAC, like who has access to what. So you want to save that as well. Because you don't want to refer to documents that this person doesn't have access to while answering their query. So that's an important piece as well. So like the pre-processing, like you were saying, garbage in, garbage out, like the pre-processing piece, like it's a lot of like typical NLP pipeline where you do cleanup before it goes in, but not a lot of it as well. Like you wouldn't want to do stemming because you're breaking down words like these were like techniques we used to use earlier, but now like these models are able to like understand the word playing and play mean the same thing. It would completely depend on a use case, the kind of pre-processing it needs, but generally I've noticed it's not a lot. The cleanup in the text is not a lot.
It's always nice when things are easier. But say people wanted to adjust their strategy moving forward. You'd mentioned the company that documented their interactions, like customer support interactions, to create documents out of that. And that can be fed in, whether as a playbook or just as general knowledge. Do you have any other advice for people who are looking to try to improve their data collection or their data structure for these systems? Is there anything they can do to like update their current processes or things to keep in mind to make sure that the data they're putting into the system is optimized?
It's like that meme. They want to build AI agents, but they go into hell and they look at the data and it's a mess. So like the customer support example that I was talking about earlier, that you mentioned now. You know what? They started with, the thing was, the CEO there. What he noticed was, like, anytime a new question comes in, someone like writes an email back, and that's it. And now we don't have that knowledge saved anywhere. And a new question, like a similar question, would come in and we'll do the same process again. Like someone goes and looks for something and like figures out the answer and sends it back. So he was like, okay, you better like write a document and send a document link instead of like writing a new answer every single time in the email. So that's how it all started. So when I got in, they started with YouTube videos initially, and then they realized it's very hard to update the YouTube videos, because with startups, what happens is their interface is changing so quickly. Like every 3 days, their interface looks different. A new button got added, a drop down thing changed. And so those screenshots and everything, if they made a video, you would have to delete the video and make it again. But with like a document, it's easier to update. Like you can change the screenshots and it would make sense. So they had like a bunch of YouTube videos. Some of them were like outdated. And then they started putting stuff in the HubSpot knowledge base. So when I came in, they had a very nice collection of like 500 so documents in HubSpot knowledge base and a bunch of YouTube videos. So typical ingestion pipeline, I build a solution. And then what we realized is conversation is not something that's useful here. No one wants to talk to a chatbot. So a Q&A system. So people can ask a question and they would get an answer. And if the answer is not suitable, there was a button that they could just say like connect to support, and it would automatically send an email to, like, a human would be looking at that email, the support team. Also, what we added was a thumbs up, thumbs down, which everyone has seen in all these interfaces. But what it did was, like, if a question comes in and we send an answer back, and if someone says connect to support, or if someone puts a thumbs down, we would take that into account and try to figure out what's up with the document. Was the answer correct? What was the confidence score like? Why were they connected to a human for this? And with that, we could like improve the documentation for them. So this whole flow was like a feedback loop of improving our documentation. Like we figured out, oh, it did pull the right document. The confidence level was high, but the answer was still not correct. That means the document was expired. Like the source reference was wrong. So we need to go work on this document. So it created a nice feedback loop for them to like keep improving their documentation and make it more diverse. Like sometimes like there was no matching documents. So it was this sorry, and that's why they connected to a human support.
And the feedback loop is exactly what you mentioned with the iteration. You're not going to nail it the first time. There's way too many edge cases. Do you have any advice on how people should try to implement that? Like if they click the thumbs down, do you just like inject into a Google sheet? Is there custom software written that helps collect and aggregate all of the incorrect use cases, or how does that part of the flow work?
In this case, I had built a custom software, sorry, because the customer support team wasn't that technical. So we wanted it to be easy for them. They could see the query, they could see the answer, they could see like what the confidence score was, and if they want, they can click and see like the chunks that were retrieved. They could like write their own comments in there and like put the link of a new document. So that was the whole interface that I'd built for them. But it could be as simple as an Excel sheet, honestly. Just like keep tracking what's happening with the system, put it in an Excel sheet, and please look at your data. So if you can look at your data, like in a healthcare company, you cannot. So if you can look at your data, like that's the best. Always look at the data, figure out what the issue is. And that is where I was saying, like, whatever you build is not going to be the final solution, because you will have to keep working on it. Like, especially with like AI, because it's so reliant on the data. And the thing with data is it gets outdated. So you need to keep working on keeping the data up to date so that the AI can rely on it.
So we find a incorrect answer, update the documentation. How then do you update the embeddings? Do you delete embeddings related to the old document? Do you replace it with a new one? Do you just like throw it in and say re-embed this? How does that part work?
That's a big question. So it depends, but sometimes the easiest thing to do is like delete the embeddings and just create new ones. It's costly, obviously. In this case, the useful thing was HubSpot knowledge base gives you date modified. So like I think every 3 days or every week, their ingestion pipeline was running, and it would go and see if this document was modified, this old document was modified or not. If it was, we were like recreating the embeddings. So it made our life easier. So it would depend. Like in your case, whatever the sources are, if they have something like this, you can utilize that, and you don't have to create the embeddings for the documents which did not get modified. Sometimes what happens is you need to create all the new embeddings. Sometimes it gets more complex. Like when it's like very costly for your system, then you would have to figure out, okay, there was a changes in this particular document, then I have to go look at all the chunks and like do the re-embedding only for those chunks, or I'll just do the re-embedding for that one chunk. But then the structure of the document changes. So it's all, I have like for my personal uses that I have found, like I have tried to like embed all the chunks. If there is a marker like this available, like date modified from the source truth, that's very useful.
Nice. Yeah, just another reason to make sure you include all the metadata. Is there a risk, and this is just general curiosity, kind of going off track a little bit, embedding models? Like we all know with LLMs, they're non-deterministic, and sometimes the same input results in different output depending on how things are processed. Do we risk the same with embeddings, where if I re-embed the same document over and over, will I always get the same vectors out, or is there a risk that it could change?
No, you won't get the same vectors out. It's probabilistic, but it would pretty much mean the same thing. It would be around the same space. So there isn't, so like that's why like generally the measure that we use for like semantic similarity is something called cosine similarity. What it does is it checks like the angle between like two vectors in that high dimensional space. This is like very simple, a 2D space. But like if you have these two vectors, it'll check the angle between them. So even if it like moves a little, the angle is still pretty much like they are similar documents. So it would be able to pull them.
For the cosine similarity, are there best practices for people to determine what the correct value is for the use case? Or is it just trial and error to say, for this given query, we want to get X amount of documents that are relevant, so we'll just keep tweaking it till we get the right number? Or is there like a good default setting? Like where do you approach cosine similarity?
So it's actually a bit of trial and error there. Like you would pull, for example, we didn't talk much about the re-ranking module, but like you pull like 20 documents or 50 documents from the chunk. It depends like how your chunks are, how many you want to pull. Like if the chunks are very tiny, you want to pull like more number of documents. And then you send it to a re-ranking module. And what that would do is like re-rank them based on like how relevant they are to this particular query. And then you can choose like the top 10 from there or top 20 from there based on the re-ranking score. The other thing also is like sometimes what we do is like instead of just pulling like top 50 documents, how we do the pull is very different. Like if it hit this chunk, it found like it was similar to the query with more than zero 0.8 as a confidence score, we might want to pull the chunks underneath it and above it so that we get the context. So it depends how the chunking was done, how the embedding was done, like what you want to pull, and then you would like run it by the re-ranking module and see like how it's performing. Are you getting the relevant chunks or not? Anything you do here that I'm saying like you want to like do trial and error, you would want to begin with like, a golden data set. Like these are the queries. These are the correct answers. These are the documents you want to pull these correct answers from. And then like when you're doing a top 10, are you checking like these like 3 documents, were they pulled in these top 10 or not, and what was the confidence score like? So you want to do this for like 100 queries, and then you would like figure out what the right parameters are for your loop.
Another way to give AI systems access to your data is by using MCP, and that can be a little bit scary, but I've been using Toolhive. Toolhive makes it simple and secure to use MCP servers. It includes a registry of trusted MCP servers. It allows you to containerize any other server with a single command. You can install it in a client in seconds, and secret protection and network isolation are built in. You can try Toolhive today. It's free and it's open source, and you can learn more at toolhive.dev. Now back to the conversation with Apurva. Could we go a bit deeper into re-ranking? Where I'm kind of curious, are re-rankers kind of mandatory for a successful rank pipeline? How do they actually influence the data flow? Do they change the embeddings, or like how do re-rankers work?
So I would suggest if you're building a RAG system from scratch, don't use a re-ranker. Just keep it very simple to begin with. But generally, like in production systems, based on the domain, we have to use a re-ranker. So basically, what a re-ranker is. So if you think about the embedding ingestion pipeline that we discussed till now, you have a query. No, you don't have a query. You have documents, and you are embedding a document using an embedding model, and you're saving the embeddings in a vector DB, right? And when a query comes in, you're using the same embedding model, creating a vector, and trying to find the similar vectors in the vector DB, pulling the right chunks based on the similarity and using that to answer the query, right? With re-ranking, what we're doing is, it's again an embedding model, but what it does is it takes a query and as well as the documents, the chunks, the embeddings that have come in, and then tries to re-rank them based on this query, which document is relevant. So what the change here is, in our previous system, like the documents were going separately, getting the embeddings created and getting saved. The query was going separately into the embedding model, getting its embedding created. In a re-ranker, the query and a bunch of documents go together and they get re-ranked based on like how similar they are to the query, like how relevant they are to the query. And then that's the result that you get in the out. So this is called a like cross encoder by encoder system. So that's the difference between like doing embedding separately and then using a re-ranker. So re-ranker is costly. Why is it costly is you cannot, once you get a new query from a user, you cannot run a re-ranker on all the documents. That's why you run a retrieval before to narrow it down to like top 20 documents, and then you run a re-ranker on top of it because it's costly and time consuming. And then you get like the re-rank documents and you can like do a filtering there and send it to the LLM. Does it make sense? So
Yeah.
you have the retrieval first, narrow down the documents, and then you send it to a re-ranker. It would re-rank based on the query, and then you would like filter it again and send it to the LLM.
Okay, so it's kind of like take top 20, re-rank it, get top 3, and then you get a higher likelihood of success.
Yeah.
That does sound like it adds a fair bit of latency to the process, though. I guess what situations, and from the user's perspective, would you want to engage with the system with the re-ranker versus just regular RAG?
Are they okay with latency or not? Do they care about the correct answer more than waiting? So it's a trade-off again. In your domain, what are the kind of users there? You know, this is where the user interface, user experience comes in. Like, what are they okay with? For example, like if you think about deep research on ChatGPT or deep research on like all a lot of these like chat products have deep research now. You're waiting for like 15 minutes and it's doing the stuff. So it's doing it in the background. So if you're okay with like writing a query and like going and doing your stuff and it would give you an answer. So this is a trade-off between like the quality versus the latency, you know? So the
Yep.
quality improves quite a bit if I can throw more compute and more time at it. And the quality goes down like if I have to make it like really quick. I can make the answer really quick, but it would not be a good answer, right?
Yeah. Are there strategies around persisting the results of a re-ranker where if someone asks another similar query, maybe not verbatim the same phrasing, but something around the same topic, it'll already know that the ones that have been ranked higher in a previous query should be referenced first?
Yeah, that is where we come into caching. So you can there are a bunch of types of cachings. So one is like the caching you would have seen in like software engineering. Like you have Redis and you are like exact matching. You have this key coming in, you'll find the value, and then you'll send it back if you're getting the same key. So it could be like someone asked, what is the capital of France? And someone asks again, what is the capital of France? It'll find like the answer is Paris and give it back to the user. The other kind of caching would be like you caching like a result from like a piece of a pipeline, like you were saying. You will want to, whatever is time consuming in your pipeline, you might want to cache it. For example, you have a system, I would say a CRM assistant, and what you noticed is like a lot of people today are asking about a particular client, and you have, I don't know, you have to pull like data from Snowflake. So your data sources could be anything, right? Like you can pull data from Snowflake that you have to analyze if you're building an agentic system. You're pulling something from Snowflake, you're pulling something from Salesforce, and you're finding like the revenue or whatever, and you can save it. And now if some other user in that team is asking about the same client, you already have the revenue, you can use it for calculating whatever they are asking you to calculate. So you have the last year's revenue, and you have to, there's a step that gets added to that to answer to this query. You have something saved. So this is like partially saving the results when the pipeline is running in your agentic system. So that is one thing. The third variety is like doing semantic similarity. So if I say, what is the capital of France? And if I say, I want to know France's capital, it would be able to figure out these two are very similar queries. So the answer would be same. But this thing is not very reliable. Like semantic similarity in the caching area is not very reliable because I can say find me good restaurants in New York and find me nice restaurants, and that's it. These two queries could be very similar. The only difference is New York, but like in the embedding space, they might be very similar, and you will have to figure out what the threshold should be. So it's like very touch and go, like not very reliable to like use semantic similarity in caching.
Are there any other considerations we should make between semantic searching and like keyword searching?
This is where we get into hybrid search. This is us going back to the retrieval piece again. Okay, so we are done with our ingestion and we have saved our vectors in the vector DB, the embeddings in the vector DB. And now if I want to do a search on top of that, a query comes in and I have to do a search on top of that. I would do cosine similarity, find the top 10. But what if you are in a field like healthcare where there are terminologies which are not used in our day-to-day life? I don't know. Maybe there's a word I cannot come up with anything like Alzheimer's, but it's like very common, like a word, a disease which we don't normally use, or an acronym there. That's where you would want to use keyword search. So a user asks, "Tell me more about whatever the acronym is," and I can go and find the documents which have that acronym. And then what I can do is do a vector search on top of that. So I filter out from like 10,000 documents, I filter like 100 documents having that keyword. And then I can do semantic similarity based on like what the user was asking. Like the user was asking about how many patients. So like whichever document has like is talking about patients. So it can do a semantic similarity on top of that. And then those top 100 would reduce to like top 50. And then you use that to send it to the re-ranker. So the thing with keyword matching is it's more exact. Like if it has the keyword, it would pull those document out. With semantic similarities, it's a bit, it would work. Sometimes it would not work. Sometimes like it would pull like the top 20, but it's not necessary. It would always pull those top 20. So it's always good to use a combination of it. And that's what is called hybrid search. So with hybrid search, what you're doing is you're using a combination of keyword search as well as semantic similarity. So you understand the sentiment of the query. Like the user was asking about patients or asking about summarizing the patient numbers or something like that. You're understanding the semantics of it. With keyword, you're also understanding this whatever the name is, HRMC, as it doesn't have a semantic meaning to it. But with keyword search, you will be able to like see a matching keyword in which documents it exists. So you're able to do a combination of those two kinds of searches and be able to find the relevant document. Not every word has a semantic meaning to it. That's where like semantic similarity doesn't work that well. And you would want to use keyword search. And a combination of both are the best.
I love the idea of hybrid search. How do we go about implementing it? Do we pass it to like the query to an LLM and say, extract the keywords with low semantic meaning? Or how do we, from a user's query, understand what we should route towards keyword and what we should route towards semantic?
So these vector DBs have that capability in which, for example, if you look at Quadrant as a vector DB, it has that capability. You just define it as a hybrid search, and you can be like, I want to give 40% weightage to keyword search and for 60% weightage to semantic similarity. So it would use a combination of that and get you like the top 10 chunks based on that. A lot of these vector DBs have that capability already, so you don't have to dive deeper into it. But generally, like based on your use case, you would want to decide like what you want to do, or you could first start with like semantic similarity, see how it's doing, and then like, okay, there are these queries with acronyms which are not working, or there are these queries with like these disease names which are not working, and you might want to use keyword search, and that's where you would want to make it hybrid. And that's where like when you are saving your embeddings, for example, in Pinecone, it creates an index. It's like a container, and you tell it like, I'm going to do cosine similarity. And then what you can do is you can also create these sparse vectors. So now it's getting very technical. So when you do semantic similarity and you're using these embedding models, the vectors that come out of it. So vector and embedding is the same thing. Embedding or a vector that comes out of it, it's called a dense vector. While when you want to do keyword search would be something like you have a dictionary already, a dictionary with like 10,000, how many words are there in English? And then if your document has like 10 words, it would like put a 111 wherever those words are in the dictionary. So it's called a sparse vector because it's pretty much empty except whatever words were there in your document. So what it would do is it would create the dense vector as well as the sparse vector and save it. And like when you come and do a hybrid search, it will do a matching on both those things. So it would do a keyword. So based on like what keywords are there in the query, it would see like which documents have the keywords wherever it is 111 for that. And it will also do the semantic similarity using the cosine similarity and find you the top K based on cosine similarity and dense vectors. Yeah.
I appreciate going into the detail. Getting a deeper understanding of these things, I think, is really important. One other area I'd like to make sure we cover, whether it's contrasting against hybrid search or just the general approach, is agentic RAG. Feels kind of buzzwordy. It comes up more and more. I'd love your experience. Have you used it? How does it compare? When should people consider it? Any insight there?
The thing with agents is everyone calls everything an agent now, and it's getting very confusing. So what I think is an agent is when you give it some capability to make its own decisions. So there is a while loop, it has access to tools and it can make its decision. Like I have to call this tool again because I haven't reached my answer, and I'm going to call the other tool because this one tool is not good. When I'm talking about agentic RAG, I mentioned deep research a lot there. Because with deep research, what is happening is it's going and doing a search, and then it's like, oh, this is not enough. Let me go do the search again. So it's like accessing a tool and trying to figure out how many times I should search or the kind of queries I'm going to use in the search. So that's what I would call agentic. I've also worked on systems where we have tried to make it agentic in the sense, like based on the user query. So like we talked about the RAG system, but we didn't talk about how it would vary based on the user query. So sometimes like the user query that comes in is like they want an answer from the document, right? And you do your typical RAG system. Sometimes what they want is like the file search, like I want the 10 documents, find me the 10 vendor documents in this folder. So it's actually a file search query. So you can use a classifier, and then based on like what the classifier classifies this query to be, oh, this is a Q&A query, or this is a file search query, I'm going to do the next step. You can define that, or what you can do is use this bigger orchestrator LLM and then give it access to these tools like a file search tool, answer retrieval tool. So like based on the query, it's able to like decide which tool to call. And like maybe the query is like find me the vendor docs in this folder and then summarize the revenue or something. So it needs a combination. I'm doing a file search tool first, and then based on the documents retrieved, I'm gonna do the answer retrieval tool. So based on these documents, I'm getting an answer. So that's where we get into agentic RAG. Like you build tools for like very narrowed down use case because they have to work. For that, you have to narrow it down. And you give a bigger LLM or an orchestrator access to these tools or these sub agents. And then based on the user query, it's going to decide like what to call, when to call, how many times to call, and when to stop and give the answer back to the user.
When people go from a development RAG system to production, what type of things should they keep in mind, both in terms of safety as well as efficiency? What are the gotchas when you have a proof of concept that works great and then you want it to go live? What should you look out for?
So you would want to add a lot of guardrails to your system. That's where like safety comes in. For example, you would want to like host these models yourself, or maybe you're okay with cloud hosted models. You don't want to call OpenAI API directly. So that's one thing, like trying to figure out your model gateway. Like how would you call these models? The other thing is like what would go inside the models. You would want to remove PII information before it goes into LLMs. Whatever comes out of these models, do you want to send it to the user directly? Maybe not. You would want to like clean that up, check like it's not abusing the user, or it's not talking about the competitor, like something. So you would want to like clean that up before you send it back to the user. So that's where the guardrail piece comes in. The other thing is like you would want to, like I mentioned this before too, like trace everything, like observe everything, like the question coming in after each step, what's happening, and like date, obviously the timestamp, the parameters that are there in the system, and the output that's going to the user, which model was accessed. So everything that was inside the system at that point of time, so that like if there's something that's going wrong, you can go back, see like what was the system state like which model was getting used that day. Maybe you're using an LLM gateway, it switches between like Anthropic, OpenAI based on like the latency, or maybe you're using a model router. Like the query is not complex, I'm going to use a simpler model. So you would want to know the state of the system at that point of time based on the user query and all the outputs from each of the pieces so that you can figure out where the problem was, so that you can go and actually solve. So that's something I see a lot of teams like skipping on. The third thing I would say is the user feedback. Since this technology is very new and the users are trying to still learn how to use it, and even we are trying to learn how to build with it and make it more reliable, you would want to like get user feedback as much as possible and like be more innovative with the user experience as well. Not everything has to be a chat conversation, right? So like having thumbs up, thumbs down, making it easier, making maybe pulling implicit feedback from the user. For example, if you're using GitHub Copilot or Cursor, like if you don't press tab or don't accept their auto answer, or maybe like you accept the code and then you make changes to it, I'm pretty sure they're taking this as implicit feedback and working on it. Like what we generated did not work for the user. So doing that, like any sort of feedback, implicit or explicit, that you can utilize to improve your system would be great.
Perfect. This was awesome. I learned a lot, and I'm sure the audience did as well. Really appreciate the masterclass and you sharing your exposure. Before we let you go, is there anything you'd like the audience to know?
Yeah, you can connect with me. Reach out to me on LinkedIn. I'm always happy to have a conversation. My website is www.apurvamisra.com, and my company is Sentick. I help out um, startups as well as like mid-sized companies with AI strategy as well as building solutions for them. And I also do speaking and run workshops. So if you need that, let me know. And you can connect with me on LinkedIn. My name is Apurva Misra, and I think my handle is Misra Apurva.
Thank you for listening to this conversation with Apurva Misra. I really learned a lot about RAG. I hope you did too. And for the implementation, I hope you just take away as it depends. It depends how you implement it. It depends on your data, your use cases. You're going to have to really consider the end use case for making your decisions throughout this process. But I hope this gave some insight as to things you should consider. I'd love to know, do you use RAG currently? What difficulties do you have implementing it? What systems, what services do you use? Please let me know down below. And if you could like and subscribe, it would really mean a lot. And I want to give a quick shout out to Toolhive for supporting the show so I can have conversations like this. And I'll see you next week.